Hi. Okay, let's go ahead and finish out section 3.3. And we're going to talk about a specific type of function. And that specific type of function is what we call a step function. Or sometimes you'll hear these called piecewise defined functions. Because these functions are a little bit different than the ones that we've talked about before. They're not defined with a single equation. They're defined sort of by depending on where you are in the x-axis. Postage is an example of piecewise defined functions. So what I have here is it's the first class mail rate chart that I picked up from the post office. And let's take a look at let's go a little simple. Let's go just stamped envelopes. So just this section that I outlined in red. If your envelope weighs 1 ounce or less, your postage is 49 cents. But if your envelope weighs even a smidge over 1 ounce, but is still less than 2 ounces, you have to have 71 cents. If it's more than 2 ounces, but less than 3 ounces, 93 cents. And between 3 ounces and 3.5 ounces, it's $1.15. And there's a footnote here that probably says that if it's more than 3.5 ounces, it's got to go as a large envelope or a parcel. But we're not going to worry about that. What we are going to do, though, is take a look at how this thing looks when we graph it, because it's kind of interesting. Sorry, I needed a drink. So I'm going to go ahead and put a couple of axes on here for myself. And I'm going to label these in a way that is convenient for what I am doing here, which means that I'm going to put 1 there, 2, 3, 4, actually, I'm going to label that a little differently, sorry. Because I only need to go to 3.5, so I'm going to do 1, 2, 3, which will put 3.5 right there. That is off your screen. Let me fix that. There we go. Now you can see it all. Hopefully that's not too small for you to see. Okay. Let's fix this again. Sorry. There, now you can see the whole thing. Okay. And for my postage, and we're going to kind of estimate this. So I'm going to put, this is going to be, oh, I know what I can do. So this is 50 cents. that will be $1. 10, 20, 30, 40, and so this would be $1.50. Now, no matter how little my object weighs, it's not going to be, my postage is not ever going to be less than 49 cents. So what that means is, if we say 49 is right here, we wouldn't mail anything that didn't weigh anything. So we're going to use an open circle. And then we're just going to go draw a line straight over to 1 ounce, where we put another dot. What that means is, if I've got a package that weighs a ½ ounce, I pay 49 cents postage. Okay, now, the minute my box goes over, my envelope goes over 1 ounce, I have to pay 71 cents. So if we say 71 is right there, then we'll go straight over from 71 to 2. So what I'm saying is that between 1.001 ounces and 2 ounces, I pay 71 cents. So I know that that's kind of not a very good approximation of 71, but we're going to live with it in the interest of time and tedium. All right, same thing goes for if I get over 2, I have an open circle at 2, and it's 93 cents until I get to, or 93 cents until I get to 3 ounces. And then it's going to cost me $1.15 for anything above 3 ounces up to 3½ ounces. This is why this is called a step function, because there are steps. Now, they won't always be flat horizontal lines in between here, but you kind of get the idea. It's defined differently depending on where we are in the x-axis. There are other examples of this sort of function in our real lives. Depending on the type of cell phone plan you have, you may have a step function for your payment. Some power companies charge more as you use more. That's another example of a step function. The United States tax code is an example of a step function. Different incomes are taxed at different rates. Okay, that closes out section 3.3. Do that homework. And this completes our conversation of stepwise functions. Our next video will be over section 3.4, which is going to talk about other graphing techniques, transformations. I'll talk to you again soon.